Hello, dear fifth graders. Welcome to another new and exciting lesson of science in which we will be learning more about this fabulous planet that we call our home, that is the Earth. We'll also be learning about the star of our solar system, that is the Sun, and of course the Moon, without which our nights would be dark and incomplete. Remember the planets of our solar system? Yes, they are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And Pluto, as you know it, is no more considered as a planet, but it is considered as a dwarf planet. If we compare the sizes of the planets that is Mercury, Venus, Earth, and Mars fall under the category of terrestrial planets because they have rocky surfaces, whereas that of Jupiter and Saturn with their humongous sizes, they are called as the gas giants. They are mostly composed of hydrogen and helium gases, while Uranus and Neptune, which are the planets which are farthest away from the sun, are ice giants, and they are made up of heavier elements. Our learning objective for this lesson is that you should be able to name the layers that constitute the Earth, namely the crust, mantle, and core, by the end of this lesson. You should also be able to describe the characteristics and composition of each of these layers, and you will also be able to explain how each layer contributes to the Earth as we know it today. If we take a glance into the formation of the Earth, we would know that when the solar system settled into its current layout about 4.5 or 4.4 billion years ago, Earth formed when gravity pulled swirling gas and dust in to become the third planet from the Sun. The Earth is the fifth largest planet in the solar system, and it is 150 million kilometers away from the sun. As you know, it is the only habitable planet which is known to support life in our solar system. The outside surface of the Earth has gradually cooled over these billions of years and it has hardened. But the inside part still remains hot and in a molten form. Now let's start digging in and let's find out more about what the Earth is made of. The layers of the Earth are namely the crust, the mantle, and the core. As you can see, the mantle is divided into an upper mantle and a lower mantle, and the core has two distinct layers, that is the outer core and the inner core. If you look at the thickness of the layers, you could see that there is maximum variation in the crust. And this is because the crust is also the thinnest layer of the earth. The temperature of the crust is around 22 degrees Celsius, but it can become much higher than this too. The crust forms just 1% of the earth's mass, and it is solid in state and it is composed of rocks like granite and basalt. The crust is made up of 8 different chemical elements, and oxygen is the most abundant in these. 46.6% of the crust is composed of oxygen. Interestingly, the crust can vary in its thickness from 8 kilometer to 70 kilometer. This is because the crust is thinnest where it forms the ocean basins, and this is called as the oceanic crust. The oceanic crust is made up of iron, oxygen, silicon, magnesium, and aluminum, and it is about 8 kilometers thick and even lesser in some places. The continental crust, whereas that is the living land where we live, is made up of rocks, and it can vary from 8 kilometers to 70 kilometers or even up to 100 kilometers where mountains are situated. Now let's move on to the second layer, which is also the thickest layer, that is the mantle. The mantle is the most solid bulk of the Earth's interior. It is about 2,900 kilometers thick and it makes up 84% of the Earth's volume. This layer is made up of molten metals, minerals, and semi solid rocks. And it is particularly rich in iron and magnesium. The molten rock is called as magma. It is a red material that comes out from active volcanoes which have just erupted. The mantle is sandwiched in between the extremely hot outer core and the much cooler and thinner crust. For this reason, the temperature of the mantle varies greatly from 1000 degrees Celsius near its boundary with the crust and 3700 degrees Celsius near its boundary with the core. In the mantle, the heat and pressure generally increases with depth. The viscosity or the fluidity of the material which makes up the mantle also varies with these factors. The uppermost part of the upper mantle is solid and it merges with the crust to form a layer that is called as the lithosphere. So the lithosphere is the coolest, the outermost, and the most rigid of the Earth's layers. The mantle just below the lithosphere is denser, it's weaker, and it's more plastic in nature, and it is called as the asthenosphere. The high temperature and pressure in the asthenosphere makes the rock soften and melt partly into a semi-molten state. The region of the mantle below the asthenosphere forms the lower mantle. The heat from the outer core makes the lower mantle hotter than the rest of the mantle. Yet, because of the intense pressure in this layer, the material is kept in a semi-solid state. So it is not solid and it is not quite liquid either. The heat from the lower mantle is now transferred to the upper layers or distributed to the upper layers because of a flow of the heated material. As you know, heated material is always lighter and tends to float upwards. Meanwhile, the cooler and heavier parts of the upper mantle will sink towards the lower mantle. Now, this process repeats cyclically to create a flow of materials or current in the mantle. And this activity in the mantle drives plate tectonics, about which we will be learning later in this video. The core. The core is the innermost layer of the Earth. It makes up 1/3 of the Earth's mass and it has two distinct parts, that is the inner core and the outer core. Both the layers are made up of mostly iron and nickel and it is in a molten state. The inner core is 1250 kilometers thick and it is believed to be in a solid state because of the extreme pressure in this layer by all the other layers of the Earth. The outer core is around 2200 kilometers thick and it is in a fluid state. In fact, it is the only layer where materials are in a fluid state in all the layers of the Earth. Because of this, it is free to move around the solid inner core as the Earth rotates around its axis, and this is what gives rise to the Earth's magnetic field. Now it's time to think about what causes earthquakes, tsunamis, and volcanoes. Are these linked in some way? The answer is yes. The Earth's outer layer, that is the lithosphere, is made up of both the crust and the topmost solid part of the upper mantle. Now, this lithosphere is not just a single solid sphere, but it is broken down into interconnected slabs or pieces called tectonic plates. A single plate can have both continental crust as well as oceanic crust in it. You can think of tectonic plates as giant rocks that float across the upper part of the mantle, that is the asthenosphere. There are about 10 to 20 such tectonic plates on the planet, and they all move at different speeds. Sometimes the plates move apart, and sometimes they bump into each other or slide against each other, creating phenomena like tsunamis, earthquakes, and volcanoes. Tsunamis are caused when earthquakes happen underwater. That is, the plate boundaries must be meeting in the oceanic crust, and when they bump into each other, that is when we experience a tsunami. The activity in the lower mantle, that is the moving of the material or the current of the material in the lower mantle, is what drives the plate tectonics, and this is what contributes to these volcanoes, earthquakes, and even mountain building processes. So this is what shapes the landscape of the earth as we know it. Now let's take a quick recap of what we have learned in this video. The Earth consists of layers that differ in composition and generally get hotter and higher in pressure as you move towards the center of the planet. The layers of the Earth are the crust, which is 5 to 70 kilometers thick, the mantle, which is 2,900 kilometers thick, the outer core, which is 2,200 kilometers thick, and the inner core, which is 1,250 kilometers thick. The crust is the outermost layer of the Earth, which makes just 1% of the Earth's mass. It is made up of both oceanic crust as well as continental crust. The mantle is the second layer sandwiched in between the crust and the core. It is also the thickest layer, making 84% of the Earth's volume. It is divided into the upper mantle and the lower mantle, and we have seen how the uppermost part of the upper mantle makes the lithosphere and the lower part of the upper mantle makes the asthenosphere. The lower mantle is extremely hot as compared to the other layers of the mantle, and the material in the lower mantle flows, giving rise to plate tectonics. Core can be distinguished into the outer core and the inner core. The outer core is the Earth's liquid layer, and it is mostly made up of iron and nickel. The inner core is under tremendous pressure, and it is solid in nature because of the extreme pressure that is exerted on the layer. The inner core is almost as hot as the surface of the sun. Therefore, liquid metals in the outer core is free to spin or move around the inner core as the Earth rotates around its axis, and this gives rise to the Earth's magnetic field. So, dear students, that brings us to the end of this video on the layers of the Earth. I hope that you've enjoyed the video and that you have been fascinated by what you have learned about the layers of the Earth. I'll see you again in the next video. Until then, goodbye, stay curious and keep learning. Bye bye.